All right, let's have a recap of 11.4. So in 11.4, we talked about arcs and chords. Again, arcs, we have a minor and a major. Chords, we know, are just segments within a circle that do not go through the center, but touch the edge of the circle at 2 points. All right, so in 11.4, we talked about how arcs and chords relate. So if I had a diameter, again, we know a diameter goes through the center of the circle from one end to the other. So this green line is my diameter. If my diameter was ever perpendicular to a chord, let's say I have my chord here. Let's change this color actually. Let's do blue, this blue chord here. Let's say my diameter, which is the green line, is perpendicular to my blue line, my chord. Well, one of the theorems that we learned in 11.4 was that my diameter actually bisects my chord, so those two parts are congruent. It also bisects my arc, so those two arcs are congruent. Okay, let's try some example problems with this. So let's say, I'm going to label these. Let's do A, B, C. Let's do X, Y, and Z. Okay, so let's say that AC is perpendicular with XZ, which we can see in our picture. Well, then that means that my chord is bisected, so XY is congruent to YZ. This also means that my arcs are congruent, so XA arc is congruent to AZ arc. Let's do some math to this. So let's say I had XY, let's say that was 7. Well, what's YZ? Well, because I know that they're congruent, YZ is the same measurement as XY, so it has to be 7 as well. Okay, well, what if I wanted the whole length of XZ? So this entire blue line. Okay, well, that's segment addition postulate, which we're used to. My small plus my small gives me my big. Well, my two smalls are 7 and 7. 7 plus 7 is 14. So then I have XZ equals 14. I know that XY is congruent to YZ, which both equal to 7. This is the one thing we talked about in 11.4. Again, if I have a diameter that is perpendicular to a chord, it bisects my chord, my diameter. Okay. Let's talk about if two chords are congruent, then their minor arcs are congruent. So I'm going to erase all this stuff. We're going to restart in here. I'm going to leave that B in the center. That's my circle B. Okay, so the other thing we talked about in 11.4 was that if I had two chords, I'm going to say, let me just draw two chords here. Let's say that those two were congruent. They may not look congruent right now, but I'm just going to make them congruent, which is fine. Let's see, does that look better? Yeah, a little bit better. Okay, let's say my two chords, in this case my two green lines are my chords, they are congruent. Let's label these. Let's call this one XY. Let's say RS. So right now I know that my chords XY is congruent to RS. What this theorem says is if I have two chords that are congruent, then their minor arcs are also congruent. So then I know that XY is congruent to RS. I get my arcs. Okay, well, let's say I didn't know that my segments were congruent. or my chords? What if I knew that my arcs were congruent? What if I knew that XY was congruent, my arc XY is congruent to arc RS? Well, if I know that my arcs are congruent, again, labeling things on my graph, on my picture, let's say I knew that my arcs were congruent. Well, because I know that my arcs are congruent, I can also say that my segments or my chords are congruent. So XY is congruent to RS, and vice versa. Okay, so essentially we just did the reverse of what we just talked about. Okay, so let's say my arc here was 70, and this was 70. Well, are my two arcs congruent? So I'm talking about these green arcs here. Well, if they're both 70, aren't they congruent? Isn't 70 equal to 70? Absolutely. So because of that, I know that my sides, or my chords, are congruent. So these two orange are congruent. Well, let's say this one was x plus 10, and this one was, let's do 25. How do I solve for x? Well, if I know that my two chords are congruent, my two orange pieces, I can set them equal to each other. So I have x plus 10 equals 25. Okay, well, we know how to solve for x. Subtract 10, I get x to be 15. If I were to plug that back in here, do I get 25? In this case, I do, so I know I did my math correct. Let's take a different route. Let's say I knew that my chords were congruent and not my arcs. So let's say I knew that my chords were congruent, my two orange pieces. Let's say this was, let's do 23 and 23. Right, well 23 equals 23, so I know that those are congruent. Well, because my two chords are congruent, my two minor arcs are congruent. So these two green arcs that I'm drawing in now are congruent. Well, let's say this one was 80 degrees, and this side was 2x plus 20. Okay, well, I know that my chords are congruent, the two orange pieces. How do I solve for x? Well, if my orange pieces are congruent on my chords, then my arcs are congruent. So because my arcs are congruent, I can set those two equal to each other. So I have 80 equals 2x plus 20. Okay, but I still need x by itself because that's my whole goal, is to solve for x. Well, let's move some stuff over. Minus that 20, I get 60 equals 2x. Divide by 2, I get x equals 30. Now, if I were to plug that x right back in there, I should get 80. Well, let's try it. 2 times 30 is 60 plus 20, which I do get 80, so my answer is good to go. Okay, so a couple things to remember with arcs and chords. If a diameter is perpendicular to a chord, then my chord is bisected. If two chords are congruent, then their minor arcs are congruent. If two minor arcs are congruent, then their chords are congruent, and vice versa.